Welcome S5SC students. Today we are going to discuss about gradient, some theorems for example and examples on gradient, divergence and curl of the vector function. Theorem: if R vector divergence of curl U vector is equal to 0, that is 0 is the scalar quantity, curl of U vector is equal to 0. Proof of this theorem: let U vector is equal to U1 I vector, U2 j vector, U3 k vector. Therefore, curl of U vector is equal to I j k divided by x divided by y divided by z u1 u2 u3 is equal to I derivative of u3 with respect to y delta u3 by delta y minus delta u2 by delta z minus j vector delta u3 by delta x minus delta z u1 plus k vector delta u2 by delta x minus delta u1 by delta y is equal to, now therefore curl of u vector, now divergence of curl of u vector, that is del dot del cross u vector, this is del cross u vector, curl of u vector, that is also equal to, we write here del cross u vector, curl u vector is equal to I divided by x plus j divided by y plus k divided by z I delta u3 by delta y minus delta u2 by delta z minus j delta u3 by delta x minus delta u1 by delta z plus k vector delta u2 by delta x minus delta u1 by delta y. Here the dot product is equal to deva deva x deva u3 by deva y minus deva u2 by deva z minus deva deva y deva u3 by deva x minus deva u1 by deva z plus deva deva z deva u2 by deva x minus deva u1 by deva y is equal to deva square u3 by deva x deva y minus deva square u2 by deva x deva z minus deva square u3 by deva y deva x minus minus plus deva square u1 by deva y deva z plus deva square u2 by deva z deva x minus deva square u1 by deva z deva y deva square u3 by deva x deva y this and this get cancelled deva square u2 deva x deva z this and this get cancelled is equal to 0 divergence of curl u vector is equal to 0 example if r vector is equal to xi plus yj plus zk vector and r is equal to magnitude of r find divergence of r vector second curl of r vector third one divergence of r raised to n r vector fourth curl of r raised to n r vector solution first divergence of r vector is equal to del dot r vector is equal to I deva deva x plus j deva deva y plus k deva deva z dot xi plus yj plus zk vector is equal to deva deva x of x plus deva deva y of y deva deva z of z is equal to 1 plus 1 plus 1 is equal to 3. Divergence of r vector is equal to 3. Second, curl r vector is equal to r vector is equal to determinant I j k deva deva x deva deva y deva deva z For r vector here, x, y, z is equal to I times derivative of z with respect to y is 0 because z is constant with respect to y. Derivative of y with respect to z, y is constant with respect to z, derivative is 0 minus j vector. Derivative of z with respect to x is 0 because z is constant with respect to x minus derivative of x with respect to y is 0 because x is constant with respect to y. Derivative of x with respect to z, x is constant with respect to z, derivative is 0 here. Thus k vector, derivative of y with respect to x, y is constant with respect to x, derivative is 0. Derivative of x with respect to y is 0 is equal to 0I minus 0j plus 0k. We get 0 vector. Del cross r vector is equal to 0. Third, divergence of r raised to n r vector. R raised to n is a scalar quantity and r vector is a vector quantity. Therefore, we know that divergence of phi u vector is equal to del dot phi u vector is equal to del phi dot u vector plus phi del dot u vector. Phi del dot u vector. Here phi is a scalar quantity, u is a vector quantity. Therefore, del dot divergence of using this, we take this in the bracket. Square. Del dot r raised to n r vector is equal to del phi, that is del r raised to n dot r vector plus phi, that is r raised to n del dot u vector, that is del dot r vector. We know that by previously del r raised to n is equal to n r raised to n minus 1 into r vector. Is equal to n r raised to n minus 2 here r vector dot r vector plus r raised to n del dot r vector. By previous result we get 3 n r raised to n minus 2 r vector dot r vector, that is r square plus r raised to n 3 r raised to n. Therefore, n r raised to n plus 3 r raised to n is equal to n plus 3 r raised to n. Fourth one, curl of r raised to n r vector. We know that the theorem here r raised to n is a scalar quantity, r is a vector quantity. Curl r raised to n r vector is equal to del cross r raised to n r vector is equal to del r raised to n cross r vector. We take it directly. Del cos phi u vector is equal to del phi cross u vector plus phi del cross u vector. We take this in the rectangle. Therefore, del cross r raised to n r vector is equal to del r raised to n cross r vector plus r raised to n del cross r vector. By previous result, del r raised to n, that is n r raised to n minus 2 r vector cross r vector is plus r raised to n by previous result from result 2 del cross r vector, that is 0, is equal to n r raised to n minus 2 r vector cross r vector plus 0. Also, cross product of same vector is 0. Therefore, n r raised to n minus 2 into 0 is equal to 0. Del cross r raised to n r vector. We join fifth in this example. Laplacian of r raised to n. R raised to n. Solution. Laplacian of r raised to n is equal to del square r raised to n is equal to del dot del r raised to n. By previous result, we know that del dot del r raised to n, that is n r raised to n minus 2 r vector. Here, divergence of scalar quantity n into r raised to n minus 2. Suppose this is phi and this is u vector. Therefore, we write directly n r raised to n minus 2 del dot r vector plus delta n r raised to n minus 2 dot r vector. We write this in reverse order is equal to n r raised to n minus 2 del dot r vector, we know that by previous result 3 plus del n r raised to n minus 2 is equal to n minus 2